Okay, so this is a little bit of a review from Math 65, thinking about how we could solve an equation that involves a quadratic, or, an x squared. How do we solve using the square root method? So in this class earlier, we solved by factoring. And you might remember if I wanted to solve this by factoring, I could go x squared minus 36 equals 0, right? That would be solved by factoring. And how would you factor that? And so what are your solutions? X equals 6 and negative 6, correct? So that's solved by factoring. We want to solve using the square root method, and that's because what undoes the square is the square root. So if you take the square root of x squared, what do you get? Yeah, but you don't just get 6. You actually still have to get plus or minus. Okay, and that's the reason why I showed by factoring is so that you can see that when you do the factoring, it's obvious that you're going to get plus or minus. You're going to get both. You're going to get both the positive and the negative, okay? But here, you have to remember, when you take the square root, you want all possible solutions. So your solutions are 6 and negative 6, and you can also check it by plugging them in. So if you go 6 squared, that will give you 36. If you take negative 6 and you square it, that will also give you 36. Okay, what could we do before we got ready to take the square root here? Yeah, you can isolate the x squared. So you can divide both sides by 2. You get x squared equals 20. And then to solve that using the square root, we can undo the square by taking the square root, right? So you take the square root of both sides. You get x equals, don't forget the plus or minus. And then the square root of 20 is the same thing as 2 radical 5. Does everybody know where I got 2 radical 5? That's a little bit of a review too. So let's think about the square root of 20 is equal to the square root of 4 times 5. 4 is a perfect square, right? So this is technically the same thing as the square root of 4 times the square root of 5. And here you get 2 radical 5. We call that simplifying the radical. Simplify radical. And just to save time, I'm not going to do the set notation or the checks, but just so you know, if you're solving, you kind of want to do that. I mean, you do want to do that. Okay. Here again, if I want to get the x squared, or if I want to get the square by itself, I could get rid of the 2. I cannot distribute the 2, by the way. That's because you have a square. I would have to FOIL it out and then distribute the 2. But if I'm going to use the square root method, I'm going to get rid of the 2 by dividing it out because it's multiplied here. I get x plus 1 squared equals what? 36. Okay, and then how do we undo this square? We can use the square root. So we have x plus 1 equals plus or minus 6, which means that you have x plus 1 is equal to 6 and x plus 1 is equal to negative 6. So now how could I solve that? That means that I have 2 different possible answers, right? So what would I do from there? I could subtract 1. I get x equals 5. I could subtract 1. I get x equals negative 7. So my solutions here are negative 7 and 5. And by the way, if you check them, let's just do a little mental check for a minute. So if I go 5 plus 1, that's 6. If I square 6, I get 36. 36 times 2 is 72. So I just did a little mental check just to save myself some space. Now the problem with using the square root property here is you cannot take the square root of this x squared unless you want to take the square root of this and the square root of this. But notice something about this trinomial. Could you factor the trinomial? What kind of trinomial is it? It's a PST, folks. It's a perfect square trinomial, just like you said. So how does that factor? Yeah, or x plus 3 squared equals 5. Now that it's set up, because it was a PST, right, which we said is perfect square trinomial, that's why it can factor this way, and we can use the square root property to take the square root of both sides. So we end up with x plus 3 equals plus or minus the square root of 5. So I have x plus 3 equals positive square root of 5, x plus 3 equals negative square root of 5. And now I can subtract 3 from both sides. I get x equals negative 3 plus the square root of 5. X equals negative 3 minus the square root of 5. Can I subtract those numbers, the square root of 5 and negative 3? Can I actually combine them? And you would say no, because square root of 5 is not the same thing as 5, right? So my solutions here are negative 3, you could say plus or minus the square root of 5, or you can separate it into those two. Those are two different numbers. If you used your Desmos, you would maybe get the decimal form of that, but I'll just leave it in radical form. We can't simplify the 5 because that's just 5, right? 5 is prime. There's no perfect square there. Like I was simplifying the square root of 20 earlier, right? I have to leave the radical 5 in there. So thinking about perfect square trinomials, PSTs, if you have a binomial squared, remember you have to FOIL it. So where are they getting the 2x from here? Yeah, 1x plus 1x if you FOIL. So think about a perfect square trinomial. If I have, this is x plus 1, and here is x plus 1. If I find the area of that square, I go x times x is x squared, x times 1 is x times 1 is x, 1 times 1 is 1. So there's, when you add that together, you get the x squared plus 2x plus 1. So it ends in a perfect square, and that's what we were looking back about factoring. What is this one going to end in? 4, right? 2 squared. What is this one going to end in? And it's always positive, right? 4 times 4 gives us 16. 5 plus 5 gives us the 10. 5 times 5 gives us 25. These are all ending, all of these PSTs are all ending in perfect squares. And what do you notice about the middle term? If we double, right? If we double the 6, I have 2 6x's, which is the reason why I end up getting the 12x in the middle. What will this end in? What will this one end in? And 64. And it could keep going on like that. Now, what happens when the sign in the middle changes? Notice that if you FOIL that out, you would get a negative 2x in the middle. But what's negative 1 times negative 1? 1. So these will all also end in what sign? Always end in a positive. PST will always end in a positive. 9, 16, 25, 36, 49, 64, right? Okay, so why is it so convenient to have these perfect square trinomials and to have them factor like this? Well, we just noticed if we have a binomial squared, then that makes it much easier to solve. So there's this strategy called completing the square. And it comes exactly from this idea of the PST. Okay, so what we notice is the term that completes the square is going to be whatever makes this a perfect square trinomial. So what would I have to have had if I have x minus 4 squared? Where did I get that 4 from? Well, the idea is if I take half of that number, that's 4, right? And then if I square that number, it gives me a perfect square here. What's 4 squared? 16. So what we're saying here is that in order to make this a perfect square trinomial so that it factors into a binomial squared, we're going to be taking half of this number, so that's the b divided by 2, or half of b, and then we're going to square that number. So half of 8 gave us negative 8. Half of 8 gave us negative 4, and then we squared the negative 4 to give us 16. We can do the same thing here, even though this is a fraction. So I'm going to take half of 2/3. What's half of 2/3? I heard 2/6. Yes, it is 2/6. Could you reduce that? It's 1/3. And notice that you could have cross-canceled. So this is equal to 1/3. So now we have x plus 1/3 squared. If I squared the 1/3, what do I get? 1/3 squared equals 1/9. So this is equal, if I factor it, to x plus 1/3 squared. This is the PST, the perfect square trinomial. This is the binomial squared. This is the factored form. And this is the perfect square trinomial. So what we did was we figured out what number could complete the square. Let's have you try it for example 2 now.